Welcome to section 2 of KMF 170 new puzzle. Let us start with question number 11. Let G be the set of integers from 100 to 999 and let n be the integer for which 40% of the integers in G are less than or equal to n. We need to find out quantity, that is 2n. So the G is the set of integers from 100 to 999. So total number of integers are 900. How can I find it? 999 minus 100 plus 1 equal to 900. Now it has said that n with the integer for which 40% of the integers in G are less than or equal to n. So 40% of G is 360. So we need to find out the integer for which 40% of G will be less than or equal to n. So how can we find out that number or integer? So the starting number is 100 and we have found that 360 is the 40% of G. So add 100 with 360 and minus 1 from the summation. So we get 459. So the integer is 459 from which 40% integers of set G are less than or equal to it. So 2n will be equal to 2 multiplied by 459. So the 2n equal to 918, which is greater than 900. So the answer will be quantity A is greater. We are in question number 12. The digits of the integer n above are the digits of the integers from 1 to 500 written in consecutive order. How many digits does n have? So we can use the counting method separately for 1 digit, 2 digits, 3 digits. So from 1 to 9 we have 9 digits, and from 10 to 99 we have 180 digits, and from 100 and 199 we have 300 digits. Same way, we have 300 digits for 200 to 299, 300 to 399, 400 to 499, and in 500 we have 3 digits. Now add all of these digits and we'll get the answer 1392. There's an alternative method. For example, from 1 to 9 there are 9 digits, and from 10 to 99 there are 180 digits. So how have I found it? There are 90 integers from 10 to 99, that is 99 minus 10 plus 1 equal to 90, and as there are 2 digits per integer, so 90 into 2 equal to 180. And from 100 to 500 we have 401 integers. How have we found it? 500 minus 100 plus 1, so 401 integers, and multiplied by 3 as there are 3 digits, so there are 1203 digits. So add 9, 180 and 1203, so we'll get the same answer, that is 1392. When the next question, here 2 sequences are given. The first sequence consists of m consecutive integers and the second sequence consists of n consecutive integers, where m is even and n is odd. Quantity A asks for the percent of integers in the first sequence that are odd, and quantity B asks for the percent of integers in the second sequence that are even. Let us take an example with numbers. So 1, 2, 3, 4, that fulfills the condition that m is even, and 1, 2, 3 is the second sequence where the condition of n is odd is fulfilled. So the quantity A is percent of integers in the first sequence that are odd. So 1 and 3 are odd. So 2 out of 4 is odd, that is half. And in quantity B, the percent of integers in the second sequence that are even. So 2 is even. So 1 out of 3 are even. Let us take the common denominator for the comparison purpose. So get 3 by 6. I have found it. I have multiplied the QA by 3 and I have multiplied QB by 2. So 3 by 6 and 2 by 6. In this case, quantity A is greater than quantity B. So option A is the correct answer. Let us understand it more conceptually. In the first sequence, there are equal number of odd and even integers. So the proportion is equal to 50%. So get n by 2, that is even, and there is also the number of odd integers. And notice that in the next sequence, one even is less than the first sequence. So the proportion is less than 50%. So what would be the numberization? That is n minus 1 divided by 2. So in this way, we can use our conceptual logic or we can take numerical example. In both cases, the answer will be A. In a sequence of 700 integers, each term after the first two terms is the sum of the two preceding terms. Okay, suppose the first term is A1 and the second term is A2 and the third term will be A1 plus A2, and in this way the sequence will go on. So the question is, which of the following would be the number of odd integers in the sequence? We need to find out the number of odd integers. Indicate all such numbers. Okay. Suppose the sequence is A1, A2, A1 plus A2. Now take the sum of A2 and A1 plus A2. So we get A1 plus 2A2. And now take the sum of third and fourth term. So we get the fifth term, which will be 2A1 plus 3A2. Okay. So we do not know whether the first two terms is even or odd. If we get these two terms, whether these are even or odd, we can find out the successive terms. Suppose A1 and A2 is even, so the third term will also be even. So the number of odd integers in this sequence will be 0. Similarly, take another example. Suppose the A1 is even and A2 is odd, so the third term will be odd. So there are three numbers cycle, that is even, odd, odd. So divide 700 by 3, we get 233 in each cycle. So in a complete cycle, we get the integer of 699. So 1 is remaining. And for that, the 700th number will be even. So 699 minus 233 equal to 466. So we get A and option F. There is another. If the first term, that is A1, is odd and A2 is even, the third term will be odd. So after completing the 3 integer cycle, we'll get the 700 term as odd. So as there are 466 odd numbers, and add one more as the 700 term is odd. So 466 plus 1 equal to 467. So we get option G also. And if we consider the sequence as odd, odd, even, we'll get the same number, that is 467. So the answer will be option A, F, and G. Let us solve question number 15. In a barrel, there are in ping pong balls leveled with consecutive integers from 1 to n, where n is an odd integer greater than 50. If a ball is to be randomly selected from the barrel, what is the probability that the ball selected will be a ball that is leveled with an odd integers? Okay, we can solve it in both conceptual and numerical way. Suppose there are 50 balls, so 50 is even, so odd number will be 25 and even number will be 25. So the probability of a ball selected that will be odd is half. Now check out the question. It says n is an odd integer greater than 50. Suppose we have taken up to 51. So the number of odd integers will be 26. At first we get 25 and now it's 26. So n plus 1. Okay. So the probability of odd integers will be n plus 1 divided by 2n. And we have only one option for that. That is option E. Let's see the next question. If n is a positive integer, then the number of prime numbers between n plus 1 and n plus 6 inclusive cannot be which of the values given in the option. Okay, let us take a numerical example. Suppose the number is positive integers is 12, so its prime number will be 3, 2, 2. So n plus 1 up to n plus 6 will be 13 to 18. How many prime numbers are there? 13, 17. So there are two prime numbers. Similarly, take another example. Suppose n equal to 11. So n plus 1 to n plus 6 will be 12 to 17. How many prime numbers are there? 13 and 17. So two prime numbers. So if n equal to 1, there will be three prime numbers. That is 3, 5, 7. Okay. If n equal to 30, we get only 31. That is one prime number. In this way, we will also get that there are some numbers for which prime number will be 0. So there left only one number, that is 6, that cannot be the number of prime numbers. For the positive integers for which the prime number can be between n plus 1 to n plus 6. Okay, so let us see the conceptual thinking for that. N plus 1 and n plus 6 are 6 integers in total, and odd and even numbers appear alternatively. Among the 6 integers, there must be 3 odd numbers and 3 even numbers. Even numbers, except 2, cannot be prime numbers. So at most, 3 odd numbers are prime numbers, plus 1 even prime number 2. The total number of prime numbers at most can be 4. So it cannot exceed 4. So our answer will be option E, that is 6. Okay, in the following question, n is an integer greater than 1000. The number of prime numbers that are greater than n and less than n plus 15. We need to find out whether quantity A is greater or quantity B is greater, or both are equal, or the relationship cannot be determined from the given information. Okay, suppose n is 1001, as it is given that it must be greater than 1000. So we have taken 1001. The number of prime numbers that are greater than n, so greater than n and less than n plus 15. So greater than n can be 1002 and n plus 15 will be up to 1000. sorry, it will be one up to 1016, because 1001 plus 15 equal to 1016. So how many prime numbers are there? 1003, 1007, 1009, 1011, and 1013. So quantity B is greater, because in case of quantity A we have got 5 prime numbers. So quantity B is greater. We're in question number 18. The integer k is the product of 4 different prime numbers. If k is divided by 22 is a multiple of 13, which of the following could be equal to k divided by 11? Okay, so k divided by 22 equal to 13n. N is an unknown number, that is a multiple of 13. So k equal to 22 into 13n. So we need to find out which of the following could be equal to k divided by 11. So 22 can be factored out by 2 into 11, and we get 13, that is another prime number, and n is an unknown number. So in both cases we have 11, just cross it out. So 2 into 13, that is 26. Now let us do an option test. 44, how can I factor it out? 2 into 2 into 11. For 78 we get 2 into 3 into 13, and in this way we have done this for C2E. Now notice 11 is in the both case. We need to find out such a number that is divisible by 26, that is 2 into 13. And another condition is k must be the product of 4 different prime numbers. So we get 2, 11, and 13. We need another prime numbers. So among these options, we get 2 such options. That is option B and option D, where there is 2, there is 13, and there is 3. Is 236 34? Yes. Okay, notice 78. It must be divisible by 26. So 78 is divisible by 26. And there are 4 prime numbers. We're in the last question. For each value x in a list of values with mean m, the absolute deviation of x from the mean is defined as absolute value of x minus m. A certain online course is offered once a month at a university. The number of people who register for the course each month is at least 5 and at most 30. For the past 6 months, the mean number of people who registered for the course per month was 20. So average is 20, least is 5, and most is 30. For the numbers of people who registered for the course monthly for the past 6 months, which of the following values could be the sum of the absolute deviation from the mean? Suppose x is 20 and m is also 20. So the absolute deviation will be 0. And take the least deviation, that is 5 minus 20 for 2 times, that is 5 minus 20 plus 5 minus 20, and take the at most, that is 30 for 3 times. So 30 minus 20 plus 30 minus 20 plus 30 minus 20. and take the 20 minus 24 one time. In this way, we are close to average 20. So get 16. Our lowest value is 0 and the highest value will be 16. So get the range. So the answer will be option C, D and E. That is 10, 30 and 60. That's all for today. Thank you.